Right, a polygon is a union of segments that meet at endpoints. Basically, it's a shape. Okay, but it's a shape where all of the lines are contained. So polygons are closed. This is a polygon. This is not a polygon. That's not a polygon. That's not a polygon. Polygons have to be closed. Things that cross each other, not polygons. Okay, but squares, rectangles, diamonds, which is actually a rhombus, trapezoids, parallelograms, shapes that you have names, pretty much, is polygons. A convex polygon has all of its diagonals on the interior of a polygon. Polygons don't have to be perfect, nice shapes. You can have weirdo polygons like this. It's still a polygon, it's still closed, and nothing is crossing each other. It's just some weirdo checkmark looking polygon. Convex polygons don't look like this. Convex polygons are your more traditional, like, they don't have dents in them. Okay, so what you have is convex polygons look like this. Non-convex polygons look like this. These are also called concave. And they look caved in. So that can help you remember that a concave polygon looks like it's been caved in, like somebody kicked it in the side. And convex polygons are like this, and the diagonals go through them. So these lines here are diagonals. And as you can see, the diagonals are all on the inside. Diagonals go from one vertex to another. That's another diagonal. If you look at a non-convex polygon, I have some diagonals that are on the inside. But then I have this diagonal over here that's on the outside because it connects these two vertices. And it can't have any outside diagonals and still be considered convex. And that's when it's called concave. Okay, so let me do this in red so it's more, these are all the diagonals. There's one that goes from here to here. So you can see most of them are inside, but then you have this one out here. Okay, so if the diagonal can go outside at all, it's not convex. Okay, an equilateral polygon means a polygon with congruent sides. Equa is a Latin for equal, and lateral means sides. Okay, so equilateral polygon has congruent sides, so that means all sides are the same length. An equiangular polygon, equal angles, angular angles. So all angles have the same measure. Okay, so you can have a polygon with all the same length sides but different angles. You can have a polygon with all the same angles but different side lengths, for example, a rectangle. But if you have both equal sides and equal angles, you're called regular. Okay. Squares are regular because they have equal angles and equal sides. An equilateral triangle is regular because it has equal length sides and equal angles. A stop sign is a regular octagon. The pentagon that gets made with like the star in the center is a regular pentagon because all the sides and angles are the same. Trying to think of other things that. Oh, the school crossing signs that are like the diamond shape. You know, the yellow diamond signs. Those are rhombuses, and those are regular polygons. Things that would not be regular, rectangles aren't regular. I mean, we think of them as a regular shape in that they're normal and we see them all the time, but they're not regular because they have two sets of sides. Like the long sides are equal and the short sides are equal, but they're not all four equal. The signs that are shaped like a pentagon, but they're more square, those aren't regular because they don't have equal length sides and equal angles. And then we talked about the diagonals already. Diagonals connect two non-consecutive vertices. So consecutive means in order. So these are consecutive vertices. The diagonal connects non-consecutive vertices. And that doesn't mean it has to be in a diagonal. It can be straight up and down. If I have a shape like this, a diagonal can actually be straight. The only polygon that has no diagonals is a triangle. Because in a triangle you have no non-consecutive vertices. Okay, so triangles don't have diagonals, but everything else will. You have to have this formula, and this formula, and this formula. Okay? Now, to find the sum of the measures of a convex polygon's angles with n sides, n just means any number of sides. So 2, 3, well, you can't have a polygon with 2 sides. 3 or more sides. 3 is the minimum. You take 180 times the number of sides minus 2. Okay. There's a reason this formula works. Because every polygon can be broken down into triangles. And then you can use the triangles to find the total angles of the polygon. But rather than do that and go the long way around, you can just have the formula. So for example, if I had 8 sides, so I'm an octagon, I would take 180 times 8 minus 2. So that's 180 times 6, which gives me 1080 degrees in an octagon. Okay. If I take the exterior angles of a polygon, now the exterior angles all go the same direction. So hold on. Okay, the exterior angles all have to go in the same direction, kind of like spokes of a wheel, like a bicycle spokes. So if one starts out going that way, I can't have another one come up this way. They can't touch each other. So they have to go out like this. And when that occurs, each one of these is an exterior angle. And then the dots add up to 360. But they're not necessarily equal. If it's a regular polygon, they're equal. But if it's an irregular polygon, they can have different measures. But they'll all add up to 360. So So they always add up to 360, but they're only equal in a regular polygon. Then you have, if you want to find out let's say we had this octagon, right? And I want to find out how much each angle on the inside is, but it has to be a regular polygon. Okay? So that means all the sides and all the angles are the same length. So if I did a regular octagon, I'd have 8 minus 2, divide it by 8. So I'd have that 1080 that I found before, but I divide it by 8 because there's 8 sides and 8 angles. That means that each angle inside would be 135 degrees. And this only works for regular polygons because the regular polygon means that all the angles are the same. If it's not regular, then all the angles aren't the same, and you can't find them that way. There's no formula for it. What do you mean, here? This one that I just drew? I think so. I'd have to actually measure the length of the sides to be sure, but I think it is. You'll be told. You'll be told a regular hexagon, regular pentagon, or you'll have a picture where it's very obviously not regular. Or you'll have a picture, let's say we do the same thing, we have this hexagon. To know for sure it's regular, it would do this. So you could see that all the sides are the same. Does that make sense? Okay. This is a hexagon because it has 6 sides. Exactly. Yeah, n is the number of sides. Now to find each of these exterior angles, if it's a regular polygon, again, it has to be regular for these formulas. This formula doesn't, every polygon. So this is any, oops, not that, this. This one is any polygon. These two only work for regular polygons, but you take the number of sides, so we'll stick with our octagon because we've been doing an octagon, and that has 8 sides. So I would take 360 and I would divide it by 8, and each external angle would be 45 degrees. So if this was an octagon, each of the red dots would be 45 degrees. So while we're getting different answers, it's still based off of that initial 180. And a circle. This is why these are 360, because if I keep, like if I were to extend this out, it makes like a circle. Right? A circle around the thing. And circles are 360.
So for using
if you have 3 sides, you are a triangle. If you have 4 sides, you are a quadrilateral. And then there's certain special quadrilaterals that have special names: rectangle, square, parallelogram, rhombus, kite, and trapezoid. These are all quadrilaterals, but they have special names because of their special properties. Pentagon, 5 sides, hexagon, 6, heptagon, 7, octagon, 8, nonagon, 9, decagon, 10, hendecagon is 11, and dodecagon is 12. And then n-gon. Okay, n number of sides. So like you would say if you had 15 sides, oh, that doesn't show very well. So just for example, if you had 15 sides, you would call it a 15-gon. There is a specific name for it, but I do not expect you guys to learn all the names of all the possible numbers of sides. That's ridiculous. So you would just take the number of sides and put a hyphen and a gon. Sides. So this is the 180 times n minus 2, and that's because it's the sum of the measures of the interior. So 180 times 11 minus 2, which is 180 times 9, which is 1620. I have the sum of the angles. I'm going to try to find the number of sides. Okay, so it's the same formula. The sum is equal to 180 times n minus 2, right? Well, I have the sum. Divide both sides by 180. So I have 1260 divided by 180, and that gives me 7. And that's what n minus 2 equals. Add 2 to both sides, and you have 9 sides. So take this, divide by 180, add 2. So basically you're working backwards. So whereas before you subtract 2 and then multiply 180, so now you divide by 180, add 2. So here's with the algebra, here's without the algebra. Same process, just written in a different way. So pick the way that makes more sense to you. Interior angle in a regular pentagon. Okay, so when it says each interior angle, that's when we have to use this formula. Okay, and it's a pentagon, so it has 5 sides. So it's 180 times 3 divided by 5. So that's 540 divided by 5. So that's 108. So each angle inside of a regular pentagon is 108. So when it says each interior is when you use this one.